In this lecture, we will talk about the polling layer. The polling layer is a key layer in the convolutional neural networks. This layer is based on the polling operation. This operation combines a set of values into a smaller number of values. Thereby, it reduces the dimensions of the input. For example, we have an input image that has the dimensions of 32 by 32. Let this be the width and this be the height. Thus, the number of pixels in the image would be 1024. Let's say we used a polling layer and downsampled it to 16 by 16. This now has a total of 256 pixels. Thus, downsampling reduced the number of pixels by a factor of 4. This means a reduced computational load on the machine. The polling layer summarizes information in small regions of the image. Thus, it does not matter that in which part of the original region was our desired information. This is called translation invariance. Let me explain this with an example. Suppose this is a 4 by 4 input feature map that is pooled into a 2 by 2 feature map. This region, this 2 by 2 region is pooled into this one box. This one region is pooled into this box. This 2 region is pooled in this box. And finally, this 3 by 3, this 3 region, this 2 by 2 region containing the digit 3 is pooled into this box. Now, suppose there is a cat here. In this one, this box will say cat. What if the cat is not here, but the cat is here? This box still says cat. It does not matter in which part of the original box the cat is. This is called translation invariance. The polling layer introduces translation invariance to the convolutional neural network. There are two types of polling, the average polling and the max polling. In this example, we do both. Suppose this is our 4 by 4 input feature map. We first do the average polling. We first place the 2 by 2 kernel here. The kernel takes the average of all these 4 values, that is 1 plus 9 plus 2 plus 0 by 4. This amounts to 3. This 3 is placed here. Now we move the kernel to the right by a stride of 2 and place it here. The kernel now takes the average of these 4. 7 plus 5 plus 8 plus 0 divided by 4 amounts to 5. Now the kernel is moved here. It takes the average of these 4 values. The average of these is approximately 5. The kernel now moves 1 point to the right. It adds up these 4 and then divides by 4 to calculate the average, and the average is 3. This 3 is placed here. This type of polling is called average polling. Now, what if instead of taking the average, our kernel picks up the max value? When it is placed here, it takes the max of 9. So 9 is placed here. When the kernel is moved here, it takes the max 8. This 8 is placed here. When the kernel is here, the max is this 8. So the 8 is placed here. And finally, when the kernel is here, the max is this 9 and the 9 is placed here. This type of polling is called max polling. We can see the dimensions shrink from 4 by 4 to 2 by 2 in each case. The formula to calculate the dimensions of the output pooled map is given by the height of the map is given by the height of the input minus the dimension of the kernel. This was the kernel and it was a 2 by 2 kernel here. This one divided by the stride. We move the kernel 2 points to the right from here to here. So the stride was 2 and finally we add a 1. The same goes for the width of the input minus the kernel divided by the stride plus 1. If we plug in the values here, that is, the height of the input is 4, the kernel is 2 by 2, so we place a 2, the stride is 2, we must get a 2. Similarly, we must get a 2 here. These are some important takeaways about the polling layer. The number of channels input to the polling layer is the same as the number of channels output by the polling layer. Only the width and the height of the channels is reduced. Suppose there are 100 channels, each with a width of 256 and a height of 256, input to a polling layer. The polling layer works by applying a 2 by 2 kernel and a stride of 2. These will be shrinked to 128 and 128. The width of the channels and the height of the channels reduced to half. The number of channels will remain the same. The polling layer will always retain important features in input, such as the edges, the textures, the shapes. It is always added after the convolutional layer. This is a design principle. Adding it somewhere else might make it vague. We can lose some important information by the polling layer because it is shrinking the size, it is losing details. The max polling might lose fine grained details. The average polling, it might blur features.